Namaste students. Once again we meet for further doubt solving in this section of kuch khaas hai. Let us proceed further. Yeah. Okay. See. A sample of chloroform being used as an anesthetic is tested by. Why are we using chloroform as an anesthetic? Because it can lead to unconsciousness when given in certain amount, and that unconsciousness is temporarily created. Not to give an overdose of that substance, till then only it will be called an anesthetic. Now, what is the need to test it? The purpose of giving chloroform is to use it as an anesthetic. But is there any harmful thing formed in this chloroform? And to understand its formation, we are testing it with some substance. Whenever this chloroform comes in contact with oxygen in air and it is exposed to sunlight, it gets oxidized to carbonyl chloride gas, also called phosgene. I have given this in my notes of haloalkanes and haloarenes, page 85, first two lines. This phosgene gas is poisonous and hence it can cause fatal conditions. To check its presence in chloroform, we treat chloroform with aqueous AgNO3. We also call it AgNO3 solution. Solution simply means here made in water. Aqueous AgNO3 or AgNO3 solution. What happens is when you treat chloroform with aqueous AgNO3 and you don't obtain any precipitate of AgCl, then that chloroform is pure and can be used as anesthetic. But if it produces, if chloroform when treated with aqueous AgNO3 produces white precipitate of AgCl, then that chloroform is not to be used as anesthetic since it contains phosgene. So to summarize, presence of phosgene gas in chloroform can be detected by making use of aqueous AgNO3. The presence of phosgene is indicated due to the formation of the precipitate AgCl when such an impure chloroform is treated with aqueous AgNO3. Now next. A compound having two OH groups attached to one carbon is unstable. Yes, we know that. एक कार्बन पे दो OH नहीं हो सकते. But it says then who is that? Who is stable in spite of having two OH on one carbon? It's not this. This will lose a molecule of water and become aldehyde. This will lose a molecule of water and become an acid. This will not lose a molecule of water. Why? I'm just writing it here in the expanded form. This carbon is having 3 chlorine and the carbon is attached to H and two OH groups like this, like this. Now what happens over here, children, is an intramolecular hydrogen bond is formed. The electropositive hydrogen attracts the electronegative chlorine. Electropositive hydrogen attracts electronegative chlorine. And an intramolecular hydrogen bond is formed. An intramolecular hydrogen bond is formed. This hydrogen bond will not allow elimination of water. Hence, this is a stable geminal diol. Not only this chlorine is an electron withdrawing group, so it will withdraw the electrons towards itself, thereby moving the OH into the molecule and will not allow it to leave. To summarize, we can say that two -OH groups can never be placed on one carbon or more than two for that matter, because such a molecule is highly unstable due to the sp3 hybridized state of two oxygen atoms, they being highly electronegative, and excess of electron density due to the two lone pairs. Such a molecule will repel and lose a molecule of water to form the corresponding compound. But when the adjacent carbon to the carbon carrying OH is having 3 chlorine or any electron withdrawing group or electronegative group on it, then such a molecule will withdraw the electron, such chlorine withdraw electron and allow hydrogen to form an intramolecular hydrogen bond with chlorine atom or any other electron withdrawing group and will not allow elimination of water molecule. And such a geminal diol will be highly stable. The name of this molecule is chloral. Chloral we have prepared in the third step while preparing chloroform in our notes, page 84. Okay, now we come to this. 20% aqueous solution. Oh, in 10th we have learned this. Electrolysis we have learned in 10th. Now when I take NaCl and NaCl is aqueous, then I know these are the ions in the solution. Now since we are doing electrolysis, it is very clear there is a cathode and there is an anode in the electrolytic cell. As we know, the cations will move to cathode and the anions will move to the anode. Anions are 2, cations are 2. We also know. In front of hydrogen, mercury, copper, silver, gold gets reduced. In front of hydrogen, mercury, copper, silver, gold gets reduced. In front of hydrogen, mercury, copper, silver, gold gets reduced. ये mercury नहीं है, copper नहीं है, silver नहीं है, gold नहीं है. So hydrogen will get reduced at cathode. Hydrogen on reduction gives H2 gas like this. Similarly, at anode, the anions will move and will get oxidized, and the rule is the simple anion will get oxidized. Among the two, simple anion is chlorine, so chlorine will get oxidized to give Cl2 like this. So children, it is very clear that chlorine gas is liberated at anode, and you know chlorine can oxidize ethanol to ethanol. Ethanol to ethanol like this. This ethanol on further reaction with chlorine will give chloral. Chloral on reaction with calcium hydroxide will give chloroform, and calcium formate. So chloroform is formed. That is the answer. 20% aqueous solution of NaCl containing C2H5 which on electrolysis gives chloroform. Again, method to prepare chloroform also we have learnt on page H84. Now here, the compound which gives negative iodoform test. Okay, we have not written the compounds. What are the compounds given in the book? Let me just check. Who gives negative iodo? Oh, okay. The first molecule they have given is ethanol. Then the second molecule which is given in the book is ethanol. Then we have acetophenone. And then there is propan 1 all. Now children, एक चीज बस याद होनी चाहिए यहाँ पर. क्या? 4 चीजें जो आयोडोफॉर्म टेस्ट देते हैं. आयोडोफॉर्म टेस्ट. आयोडोफॉर्म टेस्ट कौन देता है? वो कौन 4 हैं जो ये टेस्ट देते हैं? पहला इथेनॉल, एक ही एल्डिहाइड है पृथ्वी लोक पे. दूसरा इथेनॉल. तीसरा अल्केन 2 ऑल. और चौथा अल्केन 2 ओन. अब इधर अप्लाई करते हैं. इथेनॉल टेस्ट देगा. इथेनॉल विल गिव 2 on 1 2 on. This will also give propan 1 all. Alcan 2 all, 1 all. This will not give the test. Okay, now vestrosol is. Okay, vestrosol is basically a very good solvent. Very good solvent. Let us understand कैसे बनता है. What we are trying to understand how it, question में हमें पूछा नहीं how it is formed. They haven't asked us. But ठीक है, if we learn little more, कुछ नुकसान नहीं होगा. So see, I take ethyne and I treat ethyne with chlorine. 2 molecules. So I get like this. 1 1 2 2 1 1 2 2 tetrachloro 1 1 2 2 dash tetrachloroethane. This is also called Vestron. Very nice solvent for oils, fats, resins, etc. When I treat this with barium chloride and heat it, then I get like this. 1 1 2 trichloroethene. 1 1 2 dash trichloroethene. Also called vestrosol. Vestrosol बन गया. Vestrosol is also a very good solvent. In fact, better than Vestron. And it is also used for dry cleaning purpose. Dry cleaning की जान. Vestrosol. During debromination of meso, if you remember stereoisomerism, then you should also remember the meso compound. Meso dibromobutane, yani like this, meso dibromobutane, like this. This on debromination, यानी कि bromine उड़ाओ, debromination, which we can do using zinc. We remember zinc and a cat. Now, common sense, children, once you get this and they are asking you, ये कैसा alkene है, तो थोड़ा कॉपड़िया use करो. It has to be transbutene. We have learnt in good detail. Trans is more stable than cis-butene because trans isomer has zero dipole moment. So these were some of the questions saying kuch khaas hai, and I think I'm very confident it's clear to you. Keep studying. Love and blessings to all of you.